But today we're moving on to something pretty different, and we're finally going to talk about population parameters. Remember way back when, in August, we talked about the difference between parameters and statistics? Parameters versus statistics. I don't know, remind me what those were? Parameters referring to the whole population, and statistics was referring to some sample. So for example, I looked this up this morning. President Trump's approval rating is 37.4%. What do you think that represents?
A sample?
They must have taken a sample to get that, but they're stating it as if it's all of us, don't you think? I mean, that's what they're implying, that we all together have this approval rating. It's referring to the population. And what's interesting is down below here, kind of in some fine print, there's this little plus or minus 2%. That's kind of down there in the bottom corner when you look it up. What do you think that means?
Give or take 2%.
Give or take 2%. Why is there some give or take if they're talking about it? Yes.
Margin of error?
It's called a margin of error, but why do you think there's some error? Why can't they just tell us what it is for the whole population?
Because not everyone participated.
Not everyone participated. Did they ask you? Anybody ask you whether or not you approved? Nobody asked me either. But somehow we all got lumped into this 37.4%. So this little margin of error, we're actually going to use that exact terminology a little bit. This little margin of error tells you that we're predicting what it is for the whole population, even though we didn't ask everybody. But we're pretty sure that it's this number, give or take 2%. So give or take 2% means that the approval rating is somewhere between, if we take 37.4 plus 2, that's 39.4%. And if we take 37.4 minus 2, it's 35.4%. So what are they really saying in a sentence?
His approval rating is between 35.4% to 39.4%.
You guys all hear what she said? The approval rating is between, I'm gonna add that right up here, is between 35.4% and 39.4%. So they state it as if it's a number. This is the number, and they actually are referring to the whole population, but we all know they didn't ask us all. But what they do is they come up with this margin of error that says, because we're predicting we're going to be off by a little bit, and here's how much we're off by, which is what's called a margin of error, which is exactly where we're going. So what's happening now is somebody used statistics, they used a sample. Maybe they sampled 500 people, I don't know how many, I didn't check that. But maybe they sampled 500 people, and they used that sample to come up with this number to represent the whole population. And then there was a little bit of error because they know they didn't ask everybody. Does that make sense in terms of what they're doing? Does anybody actually know what his approval rating is for the population? I see some people shaking their heads. Why not?
It's impossible to survey everyone.
What'd you say?
It's impossible to forcibly survey everyone.
Yeah, it's impossible to survey all of us. They'll never know what the real approval rating is because they're never going to be able to survey all of us. It's just not, it's impossible to do it. Right? You can't get it. But they can fairly accurately make a guess and say, oh, we might be off a little bit. So if they've done this now and someone comes along and says, hey, I'm pretty sure that his approval rating is 50%. We have information here. I don't think so. That's not between 35.4 and 39.4. 50% seems a little too high. So what we're going to finally do in Chapter 7 on now this semester is we're going to take our sample statistics and be able to make decisions about the population, even though you can't actually ask the entire population. So we're going to be able to come up with this interval that says it's somewhere between here and here. We call this an interval. Between this number and that number. And we actually call them confidence intervals. And I'll tell you what I mean about confidence intervals before we jump into the notes. So I am 100% confident that the average age in this room is somewhere between 0 and 100. I'm 100% confident that the average age is between 0 and 100. What does that mean when I say that? What does 100% confident mean? It happens, it's for sure, it's guaranteed, it's certain. I am certain, I have no doubt in my mind that the average age, if I averaged all your ages, would be somewhere between 0 and 100. Okay, Jill, that's really brilliant of you. I probably could have done that too. But maybe I'm only 95% sure that it's somewhere between 18 and 25. The average age in this room might be between 18 and 25. It could very well be. But I'm not 100% sure anymore. Some of you might be older than you look, some of you might be younger than you look, I don't know. But I'm 95% sure that if I took everyone's age and averaged it, I would get a number between 18 and, what did I say, 25. I'm only about 80% sure that maybe it's between 20 and 24. So I can keep giving you ranges, but everyone agree that the narrower I make it, the less confident I am that I'm guessing right? So that's what a confidence interval is. It gives you an interval to predict some number, like the mean age in this case, or the approval rating. And then there's a confidence level, a percent that goes with it that tells you how sure you are. The 100% would be nice, but telling you the average is between 0 and 100 isn't really predicting it very well, right? I mean, I'm 100% sure, but I just have no clue what the number is. Where this might be, I think this one actually was, I looked it up, a 90% confidence interval. So they are 90% sure that the actual number is between here and here. So now that we've kind of talked about that one, let's start talking about the terminology. We are 7.1, which is page 86. Lots of terminology to make sure you understand the same concepts we were just discussing, but with specific language and notation, and it gets scary because there's a lot of P's. A lot of P's going on here in lots of different places, so you want to make sure you ask questions about all the notation as we go. So page 86, 7.1, estimating population parameters. So in this case, 7.1, we're going to estimate proportions or percents, like Trump's approval rating. We're estimating what percent of the people approve. If I had said it was a proportion, what's the difference between a percent and a proportion? Anybody know? Nobody? Very quiet. They're the same, except you just don't write it as a percent, you write it as a decimal. So if his approval rating, we're saying the percent is between here and here. The proportion, we're going to actually use the letter P, is between these two decimals. These are proportions, or we could have said that P, is between those two percents. Move out of the way here for you for a second. So if the question had said, estimate the percent of people that approve of President Trump, this would be the percent. This would be the proportion. We agree it says the same thing? Let's just over again. Everyone okay with the difference between proportion and percent? They get interchanged a lot. What did we just work with for the last 3 chapters that were similar to this? They got interchanged a lot. Probability and percentage, right? What percent of people, agree with the statement, or what's the probability of getting somebody? So a proportion is kind of like a probability, and a percent is still a percent, like you've seen before. P in this case represents what in words? In this example, what does P represent? About the population. I'm calling it P. What is P?
Probably second point
It's like a probability, but what's it have to do with Trump?
It's the approval rating.
Approval rating. What do we mean by approval rating? What does approval rating really mean?
How people like it.
Yeah, the percent or the proportion of the population who agree with his, I don't know what you want to say. Agree with him, agree with his job, I don't know, agree with how he's doing, I suppose. How he's doing in his job. So P is the proportion of all Americans who approve does everyone agree that's what we mean by approval rating in this case? We're talking about the proportion of all Americans. We call it approval rating for short. But I might say, what proportion of you guys actually love statistics? And that might be a percentage, maybe it's 5% of you who love statistics. That would be a proportion or a percentage. So the P is some percent of people or a proportion of people or things who fall into some category. Everyone okay with P in this case? Okay, let's go back to the notes then. So we're estimating the population proportion. We're estimating P. We're estimating P in this case. We will never know what it is because we can't ask everybody. That's why we estimate it. That's why we do statistics. We can't ask everybody, but we know enough about statistics that we can get a pretty good guess. It's not even a guess, a pretty good computation to figure out what it would be. So the first line up there says the proportion is a probability is a percent. That's what we were just talking about. Proportions and percents are interchangeable as long as you change them into percents. Those are also probabilities. So I could say that the probability that I find someone today who approves of Trump is 0.374. That's a probability, 0.374. So we were already interchanging probabilities and percents all through chapters 4, 5, and 6. So don't let those words confuse you, but they will get interchanged, just like I did in the last night's homework. So that's the first part. My example there says, if 28% of the scores on a test are higher than yours, then the probability of it being higher is 0.28, and the proportion is 0.28. Saying the same thing 3 different ways. Okay with that? So now, the point estimate is going to show up all through chapter 7. The point estimate is the number you actually get from your sample, and then you're going to add and subtract some error to that. In this case, my point estimate was this 37.4, and then we added and subtracted a little bit to get my interval. So the point estimate is the information that actually comes from your sample. And it says here that it's the best estimate for a population proportion. It's the sample proportion. It's called P hat. Remember I said there's lots of P's today? So P is what we're trying to find. Population proportion. P hat, we're all coughing today because of that smoke. I hear you all. Sample proportion. We call that P hat. Let me talk about the difference here. Somebody wants to know what percent of all Americans approve of Donald Trump. They went out and they asked some people. I don't know how many of us, I'm guessing right now, I'm saying it was 500, I don't really know. But if they asked 500 people, they got a proportion of those 500 people who said, yes, I approve. And that's what this would have been. This would have been my P hat. The number in my group, in my sample that said yes to the question. And then we use that to come up with this range to say, well, this is somewhere in here is where his approval rating really lies. So we're trying to estimate P. You will never be able to find P, but you'll always be able to get P hat. Because you just take your group and say what percent of you agree, and we're done. Okay with that? They call it the point estimate because that's our first guess, then we're going to find our margin of error from there. If I was looking for the average age of LMC students, the mean age, I would start with a sample, find their mean. That'd be my point estimate, then add and subtract to there. So that's always, the point estimate always comes from your sample. The confidence interval is what we've been talking about. A range of values to estimate the true parameter. So like here, this was a range of values. This is the interval from here to there. That's the confidence interval. And then there's a confidence level. Remember I said I'm 100% confident, I'm 95% confident, I'm 90% confident. That's what they mean about the confidence level. And look what it says there on the page. 1 minus alpha. Confidence level is 1 minus alpha. And it says it's usually expressed as a percentage. I'm going to come back to that alpha in a second here when we get to my examples. And it's the confidence that the interval actually does contain the number. So we're not 100% sure that approval rating's in there. We might only be 90% sure that his approval rating's in there. But 90% is fairly confident. You'll be given a confidence level that helps you determine how big or small your range is. Okay, so the first example here is just making sure we understand words and terminology. We're going to actually slowly work our way up to finding confidence intervals by the end of today. So example 1 says we have a 90% confidence interval that the proportion of all students with a GPA over 3.5 is 0.0997 less than P less than 0.2203. That's example 1. That is the proportion of all students with a GPA over 3.5. If I wanted to write those as percents, what would it look like? 9.97%, 22.03, just converting these numbers into percents, either by moving the decimal or multiplying by 100. So my words are, before I read on, somewhere between roughly 10 and 22%. Between 10 and 22% of students have a GPA over 3.5. So that's what we're estimating. We don't know exactly what percent of students have GPAs over 3.5. We can't go ask every student and look at every transcript. But we think it's somewhere between 10 and 22%. So look at the interpretation there. We are 90% confident that this interval actually contains the true value of proportion of all students with a GPA over 3.5. So when I say what percent of students have a GPA over 3.5, we're 90% sure it's between here and here. Because there is a chance that our one little sample was one of those rare ones that gave me something else outside of the actual range. It might be that we're wrong. There's a 10% chance that I'm wrong here. But we're 90% confident. And then notice the follow-up sentence. If we construct similar confidence intervals numerous times, 90% of them will actually come up with the true range. Because every sample I get is going to be different. If I ask, you guys and say, well, what percentage of you have a GPA over 3.5? I might have, maybe it's 12%. I ask a different group and they're 15%. If I keep doing this, I'll have all these different intervals, but most of them, 90% of them, will actually be accurate. Now, there are different ways to write intervals, and it freaks people out, but they all mean the same thing. So write down beneath where the hole punch is, alternate form of the confidence interval. I want to start working them from right to left. Right to left looks pretty much like this one, except I put the word 2 in here. From here to there. You see that? Somewhere from here to there is a confidence interval. I changed it to percents. When you do them on your calculator won't put all the stuff in there. It just puts it like this. So next to this one, or maybe underneath this one, put that that's what your calculator does. We're going to be using our calculators later to come up with confidence intervals. So you have to know that this notation really means the same as that. That P is between those two numbers. And then there's this other one down here. the first one, 0.16 plus or minus 0.0603. That looks nothing like the others. Nothing. Doesn't look like that. But come back over here. Remember where we started today? I talked about Trump's approval rating, and then we rewrote it over here like this. Those don't look the same either, but they are directly related. How did we get to here? How did we get to here? We added and subtracted this little bit right here, right? So that's why I have the visual down there. So where you have your first normal curve there, we have your first normal curve. Notice what I did down here. I kind of made it look like a normal. I have my little picture there. On the edges, I put the two numbers that we have, 0.997 and 0.2203. First off, I have a question for you. How did I know that there's a 0.16 right there? I labeled it. How did I know there's a 0.16 right there? So she wants to know, did I add the two together and divide by 2? Why would I do that? I'm trying to find the mean. I'm trying to find the halfway point, right? I'm looking for the number right in the middle. So you're always just going to average two numbers, add them up, divide by 2 to see what you have. So this number right here, if I take 0.997 plus 0.2203 and divide it by 2, if you do that, it should come out to be exactly 0.16. I'm trusting that you guys are using your calculator and checking that for me. I see some nods. So we didn't know this number in the middle, but everyone agreed that we could find it easily by taking the average. This one right here is my point estimate. That's my p-hat. The middle is always your best guess. Kind of like over here, my 37.4 was my best guess. Yes?
How did we find that middle number?
How did we find it? We averaged the two on the outside. That's what we were just saying. So if you have these two, you add them up, divide by 2, you'll get that middle number. In real life, you're actually going to work the other way. You'll start with this number and then figure out what to add and subtract. So in real life, you have a sample of 40 people in your project, say. You got 40 people in your sample and you said, how many of you like the movie Beauty and the Beast? And maybe 16% of your sample said, we do. And that would be your point estimate, the number in the middle. So it depends on which way you're given the information. So where'd this number come from? The 0.603. She's over here saying, well, we can subtract. What does she want to subtract?
0.0603.
Yeah, we're trying to figure out how far away we went. You know, over there we had plus or minus 2%. Here we're adding and subtracting something. We're adding something to go this way, question mark. And we're subtracting, it's kind of like the standard deviation, but it's a little bit more involved than that. We all agree that we had to add something to the middle and subtract something to the middle to get the edges. So to find that, what I like to do is just subtract 2 of them. It doesn't matter. I can either subtract these 2 or these 2. I'll get the same answer. Maybe I'll subtract these 2 over here. 0.2203 minus 0.16 is 0.603. So this distance right here, I'm going to rewrite it, put my green in here now. This distance right here is 0.603 just by subtracting those. You can also subtract these and check. It should be the same on either side. The beginning part of this chapter is the hardest part because you have to really understand the terminology and the notation. Once we start doing it all at once, it makes a lot more sense. Right now, we're just understanding what we're looking at. Questions on how I got those numbers now? So do we agree that this and this are the same? These are all the same? One of the first few questions you have to answer online is, take this problem and write it like this. Or take this problem and write it like that. It's making sure you understand how to find the middle and how to find the edges. So I wanted someone to ask me a question if there is one. Yes, Kirsty.
So you decided to do the 0.2203 minus 0.16, right?
Yes.
So would you add on the other side then? To get the,
To find out what this number is,
yeah, I'm just confirming.
I would still subtract here, because I'm looking for the difference between here and here. So I could also take, let me just go ahead and write it down, 0.16 minus 0.0997. So I could either subtract these two, or I can subtract those two. It's a subtracting them, because we're trying to find out how far apart they are. So either way, it'll be 0.603. The adding, which I think is what you're asking about, is from the 0.16, I can add that number, or I can subtract that number.
Oh, okay.
Does that help?
Mhm.
So speaking of that number, like segue, right underneath the pictures on your page there, it talks about the margin of error, which is exactly the same words that Hector used earlier. The margin of error is the difference between the sample proportion and the true value, the maximum difference. What I have written here in green is the margin of error. We're saying it's about 6%, it's a little bit more than 6%. We could be off by 6% one way or the other. This right here is my E. This distance right here is my margin of error. I had some number in the middle, and I added the error, and I subtracted the error. Over here, I had a number in the middle, and I added the error, and I subtracted the error. If we wanted to make a picture to go with this one, it would have looked like this. 37.4% would have been in the middle, and when I added 2 and I subtracted 2, I ended up with the 39.4 and the 35.4. Those are percent signs, this got sloppy, sorry. Okay, on what the margin of error is? From the middle up to the edges. Okay, so that's the margin of error. So then I said, in example 1, notice that p hat is 0.16. I already had mentioned that part. P hat's the number right in the middle. And the margin of error was 0.0603. So we're kind of going through that all at the same time. Okay, let's do example 2. Are we ready for example 2? They gave us an interval, and they want to change it from this form, different numbers now, change it from this form into this form. Which means you need to find your p hat, and then you're going to plus and minus your error, which is what they're asking for. I think the picture, the visual, makes it easiest. Someone draw a picture of it. I'm going to erase my Donald Trump example. Some of you can do it without the picture, and good for you, but the rest of us need to see what we're doing. So my confidence interval always is between two numbers that are balanced in the middle. What was my range? 0.230 to 0.452. And the question says to write it in this form. So what should I do? Find, you want to call it the mean, but yeah, it's really not a mean because it's a proportion. But we want to find the middle, it's called the p hat. I know you want to call it the mean because we're used to it, but right now it's a proportion. It'll be means later on. Yes, Hannah?
I'm confused where you got those numbers.
It's example 2
Oh,
at the bottom of page 86.
I'm still on example 1. I was like, where are those numbers from?
Yeah, example 2. Let's write it up here so no one else is confused. My fault. There we go. Example 2, those numbers came right off the problem. So do we agree that we want to find the p-hat? How do I find it?
You
Add
add
the
those
two
two.
numbers and divide.
Go ahead, Christian, what were you going to say?
Add the two and divide them.
Add the two numbers and divide them to find what's in the middle. So in this case, p-hat is going to be 0.230 plus 0.452 divided by 2,
0.341.
0.341. I didn't calculate it, but it looks to be about halfway between here and here, so it sounds about right to me. So that number in the middle here must be 0.341. And what else do I need now?
Subtract it,
I need to subtract to find my margin of error.
which is 0.111.
Tell me what you subtracted to get that.
I subtracted 0.452 and 0.341.
She took 452 minus 341. Because she's trying to find this distance right here. That's my margin of error. Everyone agree that she's subtracting those? What'd you say it was, 111?
0.111.
What's another way she could have gotten that? What's another way to find the margin of error?
Subtracting 2 or 0.230 from 0.3.
Subtracting these two would give you the margin of error as well. There's a third way to get the margin of error, which the book likes to point out. The book will tell you to subtract these two. But if we subtract those two, what's the problem? If we subtract these guys.
Still don't know p-hat.
We don't know p-hat, and would this give me the margin of error if I subtracted these two? What would I get if I subtracted those two outside ones?
We have to divide it by 2.
I would have to divide it by 2, because that's a margin of error and another margin of error, right? From here to here, to all the way across, that's 2 margin of errors. So the book will tell you to subtract them and divide by 2. You'll get the same answer. I don't care which way you see it. No matter what, you'll always get the same answer for the margin of error. So the directions said to write this interval, which I never wrote to begin with. Take this interval and write it in this form. So what's my answer look like?
0.341 plus minus 11.
0.341 plus or minus 0.111. Decimal points are big enough. Kind of boring in the beginning because it's just getting used to the notation. So it doesn't make a lot of sense where we're going with that. I claim that you should be able to do example 3 on your own. Top of page 87. The symbols look scary because they tell you to write this form. Like, what the heck? There's too many symbols there. I don't know what to do. Can someone explain to me why this really isn't so scary?
Because there's the answers.
We have the answer right there. Why do we have the answers right here?
Because we already have p-hat as 0.3.
Yeah, we already have p-hat, we already have e. It just wants us to subtract and to add. That's all it wants us to do. I have confidence, there's a math joke for you. Confidence intervals. I have confidence that you can do this. I entertain myself, don't worry about it. What do we get? Anybody? Nobody? 0.232 on the left? What about you? What on the right? I only did one. Sorry, what'd you say? 448? Does anybody agree or disagree with those? For those of you who don't know where it came from, I'm about to tell you. We're agreeing? So all we're doing is exactly what it told me here. The p-hat is the number it gave us. That's the first number, 0.34. And we subtract the margin of error. And over here, you take 0.34 and you add the margin of error. That's all we're doing. When you subtract, you get this number. When you add, you get this number. That is our answer. And we don't even know what the question was, you know, what proportion of somebody agrees with this statement? Somewhere between 23 and 44%-ish. Yes,
How'd you get 4.48?
0.34 plus 0.108. We're adding and subtracting. Other comments or questions? Yes.
So, how do we know that they're giving us P hat and E, where like, example 2, they're at, like, it looks the same? Okay, so, I don't know how to explain this, like,
Keep going, I think I know the answer, but I want you to try it again.
so, example 3 is asking us just to like add and subtract, but my first thought was to find mean and like, so how do we know that it's giving us that? Versus
Okay,
like problem, example 2, where it didn't give us that and we had to find it?
so example 3 was written this way. It was written in that form, so it pretty much tells you we need to do the addition and subtraction.
Okay, because it doesn't have the little P.
It doesn't
in the
have the
middle.
P is somewhere between
Okay.
here and there. So what we're doing in terms of the picture, let's do a picture for example 3, that might help. I think I just answered your question already though. But what they're saying for example 3 is, okay, we know 0.34 is in the middle. And now I want you to add and subtract to figure out what's on these edges over here. And it's telling me that I'm going to add my 0.108 to figure out what this number is, and I'm going to subtract my 0.108 to figure out what that number is. Uh-oh. I have the same thing where I updated my phone and now it like puts on these ads at the weirdest time. I don't get it. And they have sound even though my sound's off. I don't get it. Everyone clear about what we were given here? In this problem, they gave us the p hat and the e. And we had to calculate these numbers here, which we just did. 232 and 448. Where in example 2, I think I just erased it, unfortunately. Maybe it's like, oh, is that it over there? It is. Example 2, they gave us these numbers on the edges and asked us to find this number, my point's missing, and to find that number. See the subtle difference there?
Yeah, how I look at it is like, what's in the middle of the numbers is P, and so that's when we have to find that, and then when it has the plus and negative, then we use.
Mm-hmm. Yeah, when it has the plus or minus, it's pretty much telling you add and subtract. Other questions? Can you do example 4? Kirsty's like, yeah, I already did it. I already did it. Got people over here saying they already did it. I keep yapping and they're working ahead. Let's see if the rest of us can do example 4. To find p hat, what do we need to do?
Subtract those and divide by 2.
Ooh, not subtract, add by 2. We're looking for the what's in the middle. That's like the average of them. She wanted to call it the mean, but the p hat is what's in the middle. So the middle of two numbers is adding them up and divide by 2, which might even be what you did. I don't know. But we're going to find out what's in the middle by taking the average of them, which is adding them, dividing by 2. What do we get? 2368? 2638. Sorry. 2638. So that's the number that was going right here. Let's say, I don't know if you actually did subtract, Kirsty, but if you did, your answer would not have been halfway between here and here, and that would have been your clue, like, wait a minute, that can't be right. And how do I find E? Just subtract these two to see what that difference is. 0.3457 minus 0.2638, and we get, what? 0.819? Now this particular problem is not asking us to write it in this form. It just said find p hat and e. I found p hat and I found e. Make sure you read the directions. The most common questions I get in this section are, I put it in like this, it's telling me I'm wrong. Okay, but that's not what it asked for. It just said, what's P hat, what's E? You need them to write it this way, but they might ask you to write it this way. They're trying to make sure you understand the notation and you're not gonna freak out.